Okay, so we're gonna finish finally chapter 9. In chapter 9, to end, we're gonna go over 9.6b. 9.6b, um, which is angles of elevation and depression. Now, the concept is very, very easy. Um, but applying it can be a little bit more difficult, mainly because the angle of depression and elevation, a lot of these problems are story problems which students kind of tend to have a hard time with. So that's kind of the more difficult part. The idea isn't really that difficult. But on this worksheet that you have, let's go over a couple of these so that we know what the angle of depression and angle of elevation is. So um, you can see that in this figure that we have this boat right here, okay? And this boat is on top of the water, right? And then it's away from this cliff right here. Here's this cliff, rock cliff or something like that. Um, Now, there is the top of the cliff, which is right here. And so there's this angle that you can form. This right here, this line from the boat to the cliff, this line right here is the horizontal line, and the right here, this angle that is formed from the boat to the top of the cliff, this right here is what we call the angle of elevation. You can see that it's an angle that is angle upward. So we call this the angle of elevation. So in these problems, it's asking you to identify the angle, name the angle of depression and the angle of elevation in each figure. So from the boat to the top of the cliff creates an angle of elevation. So we'll say that the angle of elevation here is angle, we'll say YZR. So from Y to Z to R. From Y to Z to R. Or you can write it as RZY. I don't really care how you write that. Now that's the angle of elevation. Okay. Now you could also look at it right here where you have another horizontal line, which is this line, this horizontal line that extends past the cliff, and then opposite it's the angle from the top of the cliff to the boat. So the angle that is formed from these two lines right here, this is your angle of depression. So I'm just going to say depression and elevation. Okay. So angles of depression are angles that are downward, and angles of elevation are angles that are upward. So this angle of depression, we'll call it angle TRZ, or you could name it ZRT, whichever way you want to look at it. Okay. And that's really all this first part is. So it's identifying angles of elevation and depression. So right here in this figure, between two buildings, we have these set of windows and these set of windows right here. So we want to find the angles of elevation and depression from these windows. So right here you can see we have an angle of elevation, and this right here would be your angle of depression. So from the line LM to MR, this would be the angle of elevation, so angle, I'll say LMR, and the angle of depression would be angle PRM. Okay? So it's really not too bad of an idea. It's actually pretty easy to see where the difference between elevation and depression. Now think about it also as well. This right here, let me do this in a different color. These buildings are parallel, right? Okay, and then if you were to draw a line upwards right here from the boat to the cliff, would also be parallel. Now what that means is that right here, if these are parallel lines, then this angle here and this angle here are the same, right? And that means these angles are also the same. So the angle of depression, angle of elevation, will actually be the same because they are congruent, right? They would be congruent because of the parallel lines, and we have vertical interior. These are vertical interior angles, right? Okay, So yeah, that's pretty much what they're pretty much just like the same thing. So this angle of depression right here is the same thing as this angle of elevation. Okay, because they are alternate interior angles. Okay, so go ahead and go through these problems and identify the angle of elevation and angle of depression, and then let's talk about these story problems. Um, so story problems are a little bit more difficult for students to do, but honestly, um, if you just draw a picture, it's actually not too bad. Um, uh, yeah, they're honestly not too bad. So like, let's read this one right here. The angle of elevation from point A to the top of a hill is 49 degrees. Okay, so let's draw a hill. Okay, just draw what the picture is telling you. So we have this hill right here. Okay, and it says that this point A that we have, we'll call this point A. It's 400 feet from the base of the hill. Okay, 400 feet. And it wants to know the height of the hill. So from here to here, this is the height. And we know that the angle of elevation from point A right here to the top of the hill, this angle of elevation is 49 degrees. 49 degrees. Okay. Now that we have this set up, honestly, this isn't anything different that we've been doing before. We've been working on these type of problems just without any context of a real-life application, right? So I can set up a trigonomic function with one unknown variable to solve for. So in this case, I'm trying to solve for h. Now, h is the opposite side to angle 49, our angle of elevation. And this length here, from point A to the base of the hill, is our adjacent side. So we'd want to use a tangent ratio. So we could say the tangent of 49 is equal to the height of the hill divided by 400. And then from here, this is something that we've been doing the last couple sections. Just multiply by 400 on both sides. So 400 times tangent of 49 is equal to the height of the hill. Okay, so I have my calculator here, so I could do 400 tangent of 49, and I can see that the height of my hill is going to be 460.14. So the height is equal to about 460.1 feet. Okay. So that's really all that's to it. So again, the harder part is just setting up a picture or trying to take the context and trying to put it into a picture and putting it into a formula. Okay. Some of these can be a little bit more difficult than others, but let's see if I can find one that might be a good practice. Well, let's just go with 8. Okay. So it says find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. Okay. Now again, it's kind of hard to see where everything lines up. Where do the numbers go, right? Well, let's just draw a picture of what it's describing. So we know that there's a sun, we know that there's a telephone pole, and we know that it casts a shadow. So let's just draw a picture like that, okay? So telephone pole, got this big long telephone pole right here. Okay, we do know that there's a sun up in the sky, somewhere up here, and it's casting a shadow. Okay, so I'm going to draw a line like it's casting a shadow right here. Let's just say that. Let's get a black highlighter here. So here's the shadow of our telephone pole right there. Okay, so you see how it makes a triangle, right? So once I have this picture drawn, let's see if we can line up our numbers. Okay, so find the angle of elevation. Well, it's telling us that we're trying to find an angle of elevation. So right here, here's an angle of elevation. of the sun when a 12.5 meter tall telephone pole. So 12.5 meters is how long the telephone pole is. And the shadow is 18 meters long. So I know that the shadow is 18 meters long. So you can see here, and then again, x is the angle. That's what we're trying to find the angle. So that would, our angle, we'll say, is x. So again, we just have a function, or we have a situation where we can use a trigonomic function. And again, we have the opposite and adjacent side of x, of angle x. So let's use tangent. So tangent of angle x is equal to 12.5 over 18 meters. Now, if I'm going to get x by itself, I need to use a tangent inverse. So I'll use x is equal to tangent inverse of 12.5 over 18. And there you go. You have your equation. We just need to plug it in. So tangent inverse of 12.5 divided by 18. And I get 34.78. Okay, so that's my angle. So 34.78 degrees. Okay, and there you go. Now, go ahead and give these other ones a go. I want to look at something like 11. 11 might be more difficult to set up. So you see the, so the town of Belmont restricts the height of flagpoles to be 25 feet on any property. Okay, your friend wants to determine whether her school is in compliance with the regulation. Her eye level is 5.5 feet from the ground, and she stands 36 feet from the flagpole. If the angle of elevation is 25 degrees, what is the height of the flagpole? So this one's already has a figure laid out for you. So we're trying to find how high the flagpole is right here to see if it's in compliance. So the angle of elevation from her eyesight to the top of the flagpole is 25 degrees, but she is standing, her eyesight is 5.5 feet above the ground, and she's standing 36 feet away from the flagpole. So her goal is to find this right here. Now, we know that this distance right here is 5.5 feet. So that means this distance right here, so this is x, right? But in order to find the distance right here, so I'll say x is my green distance, and then my distance from her eyesight to the top of the flagpole is the orange one. Now, whenever I set up my trigonomic ratio, the thing is, whenever I do, I'm going to want to use a tangent ratio. If I do tangent of 25 degrees, I need the orange line. I can't use the green line because this isn't part of our tangent ratio. I want the orange line, not the green line. Now, the green line is what we're trying to find, that's the height. But in my tangent ratio, I can't use it. But here, so tangent of 25 has to be the distance of the orange line, which is the green line subtract the eyesight. So I need to take x and subtract the eyesight to find my orange line. So my orange line is x subtract 5.5 feet divided by 36 feet. So here is my tangent ratio. My tangent of 25 degrees is x minus 5.5, because that's the length of this leg right here, divided by 36. And x is the height of the flagpole. So I need to multiply by 36 on both sides, so I get 36 tangent of 25 degrees is equal to x minus 5.5. Now 36 tangent of 25, I can do that in a calculator. So 36 tangent of 25, that's equal to 16 point, we'll say 16.8. So it's equal to about 16.8 is equal to x minus 5.5. And then to solve for the height of the flagpole, just add 5.5 to both sides. And here I'll get x is equal to, so add 5.5 to that number, I get 22.2. So the flagpole is 22.2 feet. And again, the regulation says that it can't be more than 25 feet on any property. So the school is within the regulation. Okay. So again, there are a couple more problems that have this scenario where you're using the eyesight, which is above the ground. So you need to take that into account when solving for these. Okay. So go ahead, go through these problems, and I will post a key for this later, but I want to give students the option to try it on their own. So make sure that you at least try it, but then look forward to the key to be able to check your work and try and get a good understanding. Again, if it's me, draw a picture of what you can see. Draw a picture that makes sense, that fits the context of the question, and then go through and try to line up your numbers. Make sure everything's accounted for. And once you have your numbers, try and look for a trigonomic ratio that will help you solve for the unknown variable. Okay, but that should do it for this video.